Okay, so members, in this lesson we are going to see how do we handle integrals when we have a constant numerator with a quadratic denominator which is unfactorizable. If it's factorizable, we have seen that we can go on to use partial fraction, and if it's not factorizable, there it calls for completing squares and we use the time substitution. Don't forget to subscribe to the channel. Now, here you see that always, what does time substitution say? So time substitution says integral dx assumes that up we have a constant 1, then x squared plus b squared into x plus or minus c squared. All of this will be, you get a times b, then tan inverse of b into x plus or minus c over a. B can never be 0, this b can be 0. So if I have now this integral, we first now complete squares. Now to express the quadratic in this form, now we first complete squares. How do you complete squares? I think we have seen those videos, but here I'm going to do it again. You complete squares when the coefficient of x to the highest power should be 1. So now if I come to my integral 1, which is here, this, so that my coefficient of x squared is 1, there I can go on to complete squares. If it's not 1, factorize it out. We are going to see the other number. So to complete squares, I told you, you first write this. So you have x squared plus 4x. You first write this. Then plus, you get a half. You multiply this by a half. So you'll be having the coefficient of x. So it's a half times the coefficient of x, which will give you a 2. So if you multiply this by a half, you start to get 2. You square it. Because it wasn't there, you remove it. Then plus this 8. So you see that you square it, half of this coefficient of x, you square it, then you remove it because it wasn't there. This, when you simplify this, you go back to this. Now from there, you say now you get x, then plus the sign of this, then the whole square. How? Now the whole of this is going to be compressed in here. When you expand this, you go back here. When you see, when you expand this, you have x squared. Then this and this, then by 2, which is 4x. Then you square 2, which is there. Then you simplify this. When you square this, you get 4 plus 8, which will be now x plus 2, the whole square, then plus 4. The whole of this is equal to x squared plus 4x plus 8. Now you see that this one is in this form. That's why we complete squares. Now my integral, the whole of this integral, now my I is going to be now integral. Allow me to start with this, but allow me to say 4 squared is the same as 4 is the same as 2 squared. So there is this, I'm going to write it here as 2 squared, then plus 2 the whole square. So from here, why am I writing this as a square? Because I want to compare. If you compare this and this, you can start from here. Your A is 2, and here your B. So now the coefficient here is 1. So 1 squared is here, and so my coefficient there is going to be a 1. So now, if I have this, now this integral will be, you say this 1 over B, AB. It's 1 over this times this, which will be 2. Then tan inverse of B. Our B is 1. Then x plus or minus, by this side is plus, so we have the whole over A, which is a 2. Then plus that integral. That's what we are going to get for that. When I come now to this number 2, which says, number 2 says now dx over x squared minus 6x plus a 12. The same thing. We first complete squares for this. Complete squares. Now the idea, I think we have got the idea. So my x squared minus 6x plus 12 will be, we say, we first write the whole of this, then plus. When you multiply this by a negative by a half, you see that you get negative 3. You square it and you remove it. Then plus what is here, We multiply the coefficient of x, it's -6, so multiply it by a half. That's why you get -3. Then we say this one, they want to compress, you get x. This will get sign. This sign is negative. Then when you expand this, I'm sure you're going to get this because we said x squared, this and this, then by 2, -6, then we square this, which is there. Then here, when we square this, we get 9, then plus 12, which will be now, the whole of this is going to be now x minus 2 squared, then plus 3. So now I write this integral as, now it's going to be integral dx over the whole of this is here. I'm going to start with this. So 3 plus x minus 2 the whole square. Now I want to express here a square. I need a square here. So that this will be the same as integral dx over. Put a square here. I will introduce root 3. But that root 3, remove it. I square this. Then plus. Here I start we have 1 square. 1 square into x minus 3. The whole square. So from there, I think you can see that now, from here my a is root 3. The one which is under a square. And the square is that it's a. Even here, what is under square is root 3. From here, it's that this one is the same as 1 square. It will be the same. So my b here will be 1. Now substituting into this formula. Now this will be 1 over root a minus a, which is root 3. Then times b, which is 1. Then tan inverse of b, which is 1. Then x minus 3, the whole over a, which is root 3. Then plus the constant of integration. Now when I come to this, it's like this one. This should be a constant to apply this. We are going to say it's not a constant. What do we do? It's like here, my coefficient is not 1. What I do? I first factorize out this coefficient. So to complete squares for this, now my 5x squared, I first factorize out that because this is not 1, I factorize out that. We'll be having now x squared plus 6 over 5x, then plus 1, the whole in bracket. So that we divide here. What if we factorize out 5? We divide here by 5, by 5, by 5. That's why we are having that. So this will be now 5 into now. So now this coefficient is 1. So now you can complete squares. I told you, you first write this. Then plus a half. Multiply this, the coefficient of x now is 6 over 5. Multiply it by with a half. Multiply it with a half, so that this will go with the 3. So we have 5, 3 over 5. So that's why I'm going to have now this as 3 over 5, the whole square, then minus 3 over 5 squared, then plus this one there. So all you can say, the other way you can say 6 over 5 times will be 6 over 10. It's up to you. But you see that you can reduce by 2 to get that. So now, here we'll be adding 5 into now, the whole of this now. We have x plus this with its sign, then the whole square. So the whole of this is here. Then minus, here I have 9 over 25 plus 1. If we simplify that, you see we'll be adding 25 minus 9, which will be 16 over 25. So here I have 5 into, then plus 16 over 25, like that. Then after, we open our brackets back, shall be adding 5 into x plus 3 over 5, the whole square, then plus this 5 will comprise here, we add in 16 and this 5, which will be this 5 reduced to that. So this 5 is multiplied with this and multiplies that. So meaning that the whole of this is equal to that. So now my integral there will be integral of dx over, now where is the whole of this, I'm going to put this, and allow me to start with this, so 16 over 5, then plus 5 into x plus 3 over 5, the whole squared. As simple as now, I want to create a square, a square here and a square here. So this will be now integral. Now allow me to pull this constant out over. So to create a square here, I'll create a square root of 16 over 5. Of course, the square root that is there, remove it, then plus. You see, I need also square. I need this square here. So I will create also a root of 5, then square into now the whole square. So from there, members, now we can apply our formula. So this is 4 into now a times b. From here I start my a is going to be root 16. Okay, root 16 over 5, comma, my b will be root 5. The a and the b. So when I multiply them, I'll be having 1 over root 16 over 5 times root 5 and inverse of b. My b is root 5. It multiplies that. So my b is root 5 times x. The whole over root 16 over 5. So you can go and simplify this. It's up to you. You can simplify it in any way you want. So that's how we handle that. Okay, let me try to simplify this for you. You see that this one is going to be, okay, I'm going to be adding 4 up over square root of 16 is 4. Divide by root 5, then times 5, then and inverse of, now this root 5 will multiply, okay, root 5 into x plus 3 over 5 into 4 over root 5. You can even simplify this further. You can see that this one is going to cancel and so on. So that's why we have these numbers. I wish you the best. Don't forget to subscribe to the channel.